In this video, we're going to talk about how to solve nonlinear systems that represent a real-life situation. So the position of an acorn falling from the top of a 45-foot tree is modeled by the equation h equals negative 16t squared plus 45, where t represents the time in seconds. Before the acorn hits the ground, the squirrel jumps off a lower branch to catch it. The squirrel's position can be modeled by the equation h equals negative 3t plus 32. Determine the acorn's position when it was caught by the squirrel. So we have our system of equations, which is h equals negative 16t squared plus 45. And then we have h equals negative 3t plus 32. So remember, we talked about different methods of solving the system of equations. I'm going to solve this system using graphing. Here you can see I have my two equations graphed in Desmos, and I'm going to look for the intersection points to determine the solutions to my system. So this first point is negative 0.813, 34.438, and the second point is 129. So let's think about these two solutions. So we know that our x-coordinate represents t, and in this case, t represents time. So here you can see we have a negative value for t, so this solution is actually not going to make sense in the context of our problem, because we cannot have negative values for time. Well, the second solution, that's telling us that time equals 1 second, and the height is going to equal 29. Those are both reasonable values, so we can use that solution. So we'll say that the acorn's position will be 29 feet above ground, and we know that that's going to happen 1 second after it begins to fall. So now let's try this example. It says that the Fine Arts Club is preparing for their fall musical performance. The revenue they will earn from ticket sales is given by y equals negative 20x squared plus 50x, where x represents the price of a ticket in dollars. The cost of producing the play is given by y equals 120 minus 50x. Determine the lowest ticket price that will allow the Fine Arts Club to break even, where their revenue equals their cost. So we know that we want revenue to equal cost. So revenue is given by negative 20x squared plus 50x. And the cost is given by 120 minus 50x. So this is a quadratic equation. So I know that to solve this, I need to set it equal to 0. And I can do that by subtracting 120 and adding 50x to both sides. So when I do that, that's going to now become the equation negative 20x squared, and then I have 50x plus 50x, which is plus 100x, and then minus 120 equals 0. Well, notice that all of these terms have a GCF. The GCF of all these terms is negative 20. So I can go ahead and divide everything by negative 20. So I have negative 20x squared divided by negative 20 plus 100x divided by negative 20 minus 120 over negative 20, and that's equal to 0. So I have negative 20 times, negative 20 over negative 20 cancels, so I have x squared. And then plus 100 over negative 20, that's going to be minus 5x. And then minus 120 over negative 20, that's going to be plus 6, and that's equal to 0. So now to solve this, I can go ahead and divide both sides by negative 20. So when I do that, I end up getting x squared minus 5x plus 6 equals 0. So I'm going to solve this by factoring. I need factors of 6 that are going to add to negative 5. Okay, so 6 is positive and 5 is negative. So I'm going to make two negative factors. So I have 1 and 6 and 2 and 3. Okay, so negative 1 and negative 6 is negative 7, so that won't work. Negative 2 and negative 3 is negative 5, so that's the correct pair. So I have x minus 2 times x minus 3 is 0, so I'm going to set each equation equal to 0 and solve for x. So when I do that, here I'm going to add 2 to both sides, and so that's going to give me x equals 2. And then over here, I'm going to add 3 to both sides, which gives me x equals 3. Okay, so let's think about what this problem is asking us now. It's asking us to find the lowest ticket price that allows them to break even. Well, ticket price is x, so all it really is asking us for in this problem is the value of x. So we have two values of x equals 2 and x equals 3, that are both reasonable solutions. But the lowest price out of these two is going to be 2, so we're going to recommend that they charge $2 per ticket so that they can keep their prices low, but then also break even. So now you can go ahead and pause the video and try doing this example on your own. So our clay pigeon is launched and traveling along a parabolic path represented by this equation, and then x is going to represent time and y represents the height of the pigeon. An archer shoots at the pigeon and the arrow is moving along the linear path represented by this equation. So to solve this, we're going to set the parabola equal to the line, right? Because we want the pigeon and the arrow to intersect. So we set this equation equal to 0, and I chose to solve this using the quadratic formula. I first calculated the discriminant, which is 529. That is positive, and it is a perfect square, so I know I'll have 2 real rational roots. So the quadratic formula helped me find those roots. I found 2 solutions, which were x equals -3/5 and x equals 4. So remember that x represents time, so -3/5 is a solution that doesn't make sense. So I only used 4, and then I went back and plugged into the linear equation, and so I got y equals 15. So that means that after 4 seconds, the pigeon will be 15 feet above the ground when the arrow will intersect the pigeon's path. So you can write and solve a nonlinear system to represent a real-life situation. These systems can then be solved by graphing or using algebra.